All right, so here's the most vital thing that you have to understand, is that gas is capable of doing work on a system. So like if I push this down, I did work, right? But if I let go of it, what does the gas do? It does work because it exerts a force through a distance. It makes that plunger go up. So here's the first thing that you have to get, is the idea that gas is capable of doing work. Now, whenever the volume gets bigger, doesn't make any difference in the process. When the volume gets bigger, when you increase that volume, work is going to have a negative number. So, golden rule number one. If you see the volume getting bigger, work is negative. And here's the reason why. Because when that was compressed, and I let go of it, that gas, it costed energy. Because it had to push against the syringe that was trying to hold it down. So, here's the analogy. Let's say I'm going to take James, and I'm not going to do this to James, because I actually like James, in spite of the fact that I do kind of scowl at him at times. But I'm going to wrap James in a layer of saran wrap. Okay? Now, at this point, James is not comfortable. He's going, man, I can't talk with my arms, I can't draw on the board and talk about objects of prerogatives or whatever you were talking about yesterday in Encore with grammar. Okay? And James is going, this sucks. He goes, I got to be free. So James is going to break free, right? He's going to increase his volume. So but that's going to cost James energy. Okay? That is going to cost him energy. So at the end of the day, James is going to be a little bit more tired because it cost him energy. So the same thing is true here. When I compress this gas, right, that's like me wrapping James in saran wrap. James doesn't like it. So as soon as he gets the opportunity, what's going to happen? He's going to be a free man. The same thing is going to happen with this gas. So anytime a gas makes the volume bigger, anytime the volume gets bigger, work is going to be a negative number. Now, what if we reverse this process and we go from 0.5 to 0.1? So if we make the volume smaller, look what happens mathematically. What's the only thing that changes out of this equation? Instead of having the natural log of 0.1 over 0.5, I take the natural log of 0.5 over 0.1. Guess what? I get the exact same number, but it is positive. Okay? Crazy. So, here's the golden rule. If volume is getting bigger, yes, James?
So since you can have negative work, can you have negative power?
Yeah.
Yes. But not really in terms of a gas. Okay? But typically with that, you're talking about like a larger system in terms of what this is going to do. This is going to drive a mechanical system. So what you'll talk about is the power of the overall system.
Okay.
Okay, that's a good question. So, if volume gets bigger, work is negative. If volume becomes smaller, work is going to be positive. Okay? Now, here's where you get into prepositions. If the volume is getting bigger, what we're saying is work is done by the gas. So, work done by the gas is the magic code for volume is getting bigger. Because the gas inside is pushing against the cylinder trying to hold it down. Okay? So the magic word is, if you see work done by the gas, that's the magic phrase for, oh, work is going to be negative, volume is going to get bigger. Now, if the volume becomes smaller, we're going to use the phrase on. Okay? So if the work is done on the gas, in other words, I'm physically going to do work on the gas. I'm going to exert a force through a distance, and I'm going to make that volume smaller. So work done on a gas means the volume becomes smaller. Work is going to be a positive number. So if volume is smaller, work is positive, you associate that with the word on. If work is negative, it means the volume is getting bigger, and you associate that with the phrase by. So work is either done on a gas or work is done by a gas. If it's done by a gas, it's making something bigger. So it's like James is doing work on, or the work is being done by James on the saran wrap. Okay? It's going to cost him energy. He's going to be tired. But if I confine James, I'm doing work on James, and I'm making him volume, and I'm making that volume be smaller. Cool with this? Okay. Now, here's the next ramifications of this. So here's the next big equation. This is all on the back side of your equation sheet. The next one is this. Delta U equals three things, or two things. It equals 3/2 NR delta T. And delta U also equals Q plus W. Now, let me explain what delta U is. Delta U is the total energy of everything in the system. Okay? So when you talk about thermodynamics, you talk about two things. You talk about the system and you talk about the surroundings. So when I'm talking about the system, I'm talking about what's happening within the confines of this cylinder. That's what I'm talking about. Okay? I'm not talking about what's happening in Paris. I don't care. The only thing I'm focusing on is what's happening within the confines of this cylinder. Nothing else. So delta U is the sum total of kinetic energies, potential energies, translational energies, kinetic energies, everything. This is all of the energies. All of the energies. Now, here's the deal. So let's talk about an isothermal line. So by definition, if you have an isothermal line, what's staying constant?
Temperature.
Temperature. So if I have an isothermal line, what's my change in temperature? 0. So check my math, and if I take 0 times 3/2 NR delta T, I'm going to get 0. So on an isothermal line, delta U equals 0 because there's no change in temperature. So isothermal lines are simple to remember about this. Delta U is going to equal 0 because there's no change in temperature. By definition, that's what that means. Now, let's talk about this. Delta U also equals Q plus W. What do you think the W stands for? Work. Ah, so here's the work side. Okay? Now, this Q is the Q that we talked about yesterday. Okay? So Q is a measure of thermal energy that's flowing in and out. So this is thermal energy. Oh, if I can spell that.
We can't read it.
Thermal as opposed to thermal energy. Okay? There we go. Energy. So, what do you think units of work is going to be measured in? Joules. So, what do you think Q is going to be measured in? Joules. So, what do you think delta U is going to be measured in? Let's complete the trifecta. Joules. Okay? Now, when you talk about this thermal energy, this is the same Q that we talked about yesterday. This is a measure of energy flowing in and out of the system. So here's the basic idea. We're going to look at delta U equals Q plus W. Now, I want everything that we've talked about before, momentarily I want you to block out of your minds. Okay? I want you to block out of your minds right now. And this also equals 3/2 NR delta T. Okay? So momentarily, forget everything that you know about pressure volume graphs. Block that out of your mind. We're going to get back to it. I don't want that to permanently go away. I just want you to momentarily squirrel that away someplace else. So, let's say that here's my syringe. Okay? And I'm going to lock this thing in place so it can't move. And I'm going to take this syringe and I'm going to put it into a hot water bath. Okay? Y'all seen hot water baths in Chem 1, right? Boiling water, you drop it in, there you go. So, I'm gonna take this syringe, locked in place, and I'm gonna heat it up. So, here's my syringe. Ladies, don't ever date a guy that says that on a regular basis. So, it's locked in place. And I'm gonna put that syringe in a boiling water, okay? So, is work gonna be done?
Yes.
No, it won't.
No.
Why?
Because it's not applying force.
I'm not allowing it to change. Work only happens, remember, work only happens if you change the volume, right? If I make this cylinder move through a distance, if this is locked in place, I do no work. So, this is going to be 0. What do you think is going to happen to my change in temperature? Is my temperature going to go up or is my temperature going to go down? Up. Trent, you don't need to get that dramatic. Okay? So the temperature is going to go up. So, is N ever going to be negative?
No.
Why?
Small.
It's number of volts. What about R?
No, it's constant.
It's constant, right?
Yeah.
So, could my change in temperature be a positive number?
Yeah.
Yeah, if my temperature goes up. So, if my temperature goes up, this is 3/2 NR delta T. Oh, that's kind of cool. Right. So, if my temperature goes up, what's going to be my sign of delta U?
Positive.
Oh, that's going to be a positive number. Oh, that's kind of cool, right? So, if energy flows into the system, right, temperature goes up, delta U is a positive number, and Q therefore has, by default, Q has to be a positive number. So, here's my system, okay? However you want your system to be, a box, a squirrel, a ball, a penguin, I don't care. Whatever your system is. So, if energy is flowing into the system, that means Q is a positive number. Okay? Energy flows in, Q is positive. If energy flows out of the system, okay, guess what? Q is going to be a negative number. So, let's say for example, okay, Emily walked in this morning, she had a nice cup of coffee, right? I'm guessing that was pretty warm when you got here. Now what's happened to the temperature?
It's cooled down.
It's cooled down. So what's the sign of Q for your coffee cup? Temperature went down, right?
So it's a negative.
It's a negative number.
Yeah.
Because energy has flowed out of the coffee cup, right? But to make that water hot initially, what did you have to do? So initially Q was a positive number. So the styrofoam cup basically tries to eliminate a heat loss. It tries to mitigate the outflow of thermal energy. So when something cools down, Q is negative because energy is flowing out of the system. When energy is flowing into the system, Q is positive. So here's what we've got. And if you keep this in mind, everything else is going to be cool. You're going to have 4 signs. W and Q. So if W is a positive number, let's just summarize this right now, because if you memorize nothing else, you have to get this straight. If Q is positive, what's happening to the volume? Is volume getting bigger or is volume getting smaller?
Small.
Smaller. So I'm going to decrease my volume. Okay? And that means that work is done on the system. Okay, that's the preposition that goes with this. If work is negative, that means the volume is getting
Bigger.
Okay? So we're increasing the volume, and work is being done by the system. Okay? Now, let's talk positive Q. So, if you think about this in terms of Emily's coffee cup, if the energy is flowing out of her coffee cup, what's going to be the sign of Q? Negative, right? So this means that energy is flows out, right? So energy is flowing out of the system, it's cooling down. If you have a positive Q, what does that mean? Energy flows in. Okay? got this. If you have this straight, you have a fighting chance. If you don't know these, you are dead in the water.
What do you mean by on and off?
Okay, so like for example with this one, if I say work is done on the system, that means I'm pushing down on the cylinder.
Okay.
Okay, so this is, if you want a visual, so here's this demo that we did, and here was the plunger, and so here's my hand, and this is me pushing down. Okay? Now, if work is done by the system, here's that same plunger, right? But then that plunger starts here, and that plunger is pushed up by the gas.
Okay.
So these little particles in here are pushing against it and then make it go up. Okay?
So that's
So
when you release it.
this is on, this is by. Okay? What?
Yeah.
Okay. Energy flows in, energy flows out. If nothing else, if you listen to all the lectures that I've given you, it's rare that I've ever said, this is something you just have to memorize and have down cold. This is the one thing. Make 4 flashcards, okay? Tattoo it on your best friend's forehead so when you look at him, you go, boom, okay? Text it to a friend. I was kidding. Stop! Okay? Set up a group chat out of text and say, okay, hey, everybody, what does it mean if work is negative? Okay? What does it mean if work is positive? Positive Q, negative Q. Because if you get this, life becomes much simpler. If you don't understand this, you're trying to swim with a rock tied around your waist. It is not going to end well. Okay? All right, now, let's go back to this. So, we said on an isothermal line, we're going in this direction. True?
True.
True. The area underneath here represented what?
Work.
Work. And work had a positive or negative sign.
Negative.
So this is a negative number because work is being done by the system. We're making the volume get bigger. Okay? So, here's the cool part of this. We found the value of work. What did we have for the value of work? Negative was 392?
Yeah.
Okay? So, moment, this is going to be an epiphanal moment. We said that delta U equals Q plus W. But that also equaled 3/2 NR delta T. What was my change in temperature on an isothermal expansion?
0.
This is 0. So what does that mean delta U is?
0.
That means delta U is 0. So what does that mean Q plus W have to add up to?
0.
So if my W is
Then green.
negative 392 joules, what does Q have to be?
392.
Positive or negative?
Positive.
Oh, positive 392. How cool is this? Now, so here's what happened. Okay, here's what happened. Here was the syringe, right? Here's the syringe. I have a positive Q of 392. That's joules, not newtons. That's joules.
Nice.
Okay? So, what was the direction of energy flow in, was energy flowing into the syringe or out of the syringe?
In.
In. Oh, so we had some thermal energy flowing into the syringe. How could we, what could I physically do to dump some thermal energy into this syringe?
Heat it up.
Heat it up, put it in a hot water bath, throw it in the microwave, okay? Do something, right? So maybe even just hold it in my hand. That's going to provide some thermal energy into it. So energy, my thermal energy, is flowing into it. Now, here's what's also happening. Because of the fact that the volume can move, I'm going to take this energy and I'm going to throw it in there. But then it's going to take that energy and it's going to make the volume get bigger. Okay? So it isn't going to hold on to that energy, it's going to do something with it. It's going to make that volume get bigger. So if you ever know how much work that you've done, you know how much energy had to go into it. Now, they can make this analogy. Okay? So let's say that upon my passing, I think, okay, you know, Emma is going to do great things in life. So upon my passing, I'm going to say, here's the deal, Emma. I'm going to leave Emma $50,000. Okay? So, no, don't nod your head yet, okay? Don't nod your head yet, okay? But I'm gonna leave Emma $50,000. So she's gonna get a positive inflow into her bank account of $50,000. So 50 grand is going to go into her bank account. So that's Q. It's going in. But, here's the caveat. She can't keep the money. Okay? Emma has to do good with the money. Okay? She has to spend the money to make the world a better place. She has to do work with the money. So, I'm going to dump $50,000 into Emma's bank account upon my passing. But with the condition being that she doesn't keep any of it. She has to go out and she has to do work. She has to make the world a better place. She builds an orphanage, she buys playground equipment, she puts solar panels on the school. She does something with it, okay? She's going to make the world a better place. So her overall bank account doesn't change. I gave her a lot of money, but guess what? She's got to spend a lot of money. Now, what if I dump $50,000 into Emma, and this wouldn't happen because this is why I picked Emma, and Emma says, you know, screw it, I want to go to the Bahamas, okay? I'm not going to do any work with it. You know, screw it. I'm going to keep all of the money. So if I dump 50,000 joules into Emma and she doesn't spend it, what becomes of her delta U?
Positive 50,000.
That's up 50 grand. Okay? That's up 50 grand.
Lots of energy.
Lots of energy. Guess what? Then what has to happen to her temperature then?
It's gonna go.
Her temperature is going to go way up
Oh, that's pretty bad.
because she's going to go, I'm going to hell. Work can't left me all this money, and I'm supposed to be good with it, and I'm laying on a beach in Jamaica. Oh well. So, but
That's bomb.
her temperature's going to go up because she's going to feel this internal conflict that Burkamp left me all this money. He thought the world of me, and I didn't spend it on doing anything good. But boy, am I having a good time. Oh well. Go get over it. He's dead. I don't care. Okay. So, but you wouldn't do that. Okay. All right. Now, James, you notice I didn't pick James for this story. Okay?
I'd invested.
Okay, there you go. You'd make even more money with it. Okay, so do you have the isothermal line figured out?
Yeah.
That's the most complex. Now everything else is going to be so much more simple. Okay? It's going to be so much more simple. So, let's go back, and we're going to start at the same spot again. We're going to start at 0.1 cubic meters. We've got a pressure of 2440 newtons per square meter. But instead of going down like this to 0.5, now we're going to go across. Like this. Okay? So, but here's an interesting thing that happens. Okay? In both situations, do I go from 0.1 to 0.5?
Yeah.
Yeah.
Do I end up with the same final volume?
Yeah.
But is the process the same?
No.
Completely different. So if I have a horizontal line, what type of process is this? What am I keeping constant? Pressure. Oh! So this is going to be isobaric. Oh, right, cool. So go to the ideal gas law. PV equals nRT. True? So if I go across, what's happening to my pressure?
Staying the same.
Staying the same. What's happening to my volume?
Changing. Getting bigger.
It's getting bigger. Oh, so I go across, as I go across, I'm increasing my volume. Okay? So this syringe is getting bigger and bigger and bigger and bigger and bigger. But to do this, since there's an equality sign here, what has to happen to the temperature?
Gotta go up.
Oh, temperature's got to go up. Ooh. So I got to have some increase in temperature. Oh, that's cool, right? I'm not sure it's not cool. It's going to be warm. So here's the question: can I find this new temperature?
Of course.
How?
That pressure.
Okay. Do I know the pressure? Do I know the volume?
Yeah.
Yes.
Do I know nerve?
Yeah.
Yes.
The only thing I don't know is. Okay, so give me a T.
T.
There you go. Nice. Okay. So I got PV over NER equals temperature. Now, what was this temperature? 293?
Yeah.
Okay? So I got to figure when I calculate this temperature, it's going to be bigger than.
93.
So somebody take the pressure, which is 2440, times my new volume, which is 0.5, divided by 0.1 times 8.314. Okay, just the ideal gas law constant. Here's the number of moles, 0.1.
1467.
What'd you get?
1467.
1467
67.
Kelvin. Now, that's pretty warm. Okay, that's smoking, right?
Yeah.
Because you consider, we went from basically room temperature to close to the surface of the sun. Okay? Or at least hot enough to melt iron. So, this temperature went up quite a bit, okay, because we had such a big increase in volume. So here's what's happening. Physically, what would I do? Would I be dumping energy into the system, or would I be taking energy out of the system? I'm going to dump a whole bunch of energy into the system. Because now, look, did my temperature change?
Yes.
Yes.
What does delta U now not equal?
0.
Does not equal 0. Because as soon as you have a change in temperature, you have to have a change in delta U. Now, look. We got area underneath the rectangle, right? So here's the next big equation. Is that work equals negative P delta V. You're going, wow, Bergkamp, why don't we use the natural log one that we just used? Because here's the reason I'm going to use this and not this one. Because the first one we had was nRT, natural log of volume 1 over volume 2. I can only use this if I have a constant temperature. Okay? Right? And with this one, I don't have it. With this line going across, I don't have a constant temperature. This is why I can't use this on an isobaric line, because my temperature is changing. So that's why you have to pay attention to what you're going to have. Now, we'll talk about the significance of this negative sign in just a second. So in this situation, I've got a negative P, negative 2440 newtons per square meter. Now, change in volume. That's going to be V minus V naught. What's my initial volume? 0.1, right? My final volume is going to be
0.5.
0.5. So when I take my final, which is going to be 0.5 minus 0.1, if I take 0.5 minus 0.1, is that a positive or negative number? Positive. But here's the deal. But my volume is getting bigger. So my volume gets bigger, so what does the sign of my work have to be? Positive or negative? My volume is getting bigger.
Negative.
Negative.
Well, that's got to be a negative value. Oh! So here's the significance of this negative sign in front of this calculation, is that it makes the signs consistent. So now, somebody take 2440, basically times 0.4.
976.
What'd you get?
976.
Negative 976 joules. Now, interesting thing happens. What was this work? That was like negative 392? Now, look at this. Underneath this line, that work was negative 392. This line up here, you'll notice is negative 976. So visually, how could you tell that this work here going across is going to be bigger than this work here?
More surface.
There's more area, right? So even though I end up with the same change in volume, this is going to require a lot more work because the area is a lot bigger. Okay? So just because you have the same change in volume doesn't mean that you have the same work. Okay? Cool with this. Now, so as I'm going across, okay, what's happening to the volume? Volume is getting bigger, right? What's happening to my temperature?
Getting bigger.
It's getting bigger. Now, so look at this. So on a horizontal line going across on a pressure volume graph, you're increasing the volume. Is heat being dumped into the system or taken out? In. So I've got a positive Q because I'm dumping energy into the system. True?
Yeah.
But work is going to be a
Negative number.
negative number. But what's my overall sign of delta U? What's my overall change in temperature, positive or negative?
Positive.
Positive, because my temperature went up. So delta U is going to be a positive number. So look at this. Delta U equals Q plus W. W is going to be a negative number. Q is going to be a positive number. So which one has to be bigger, my Q or my W?
Q.
So here's what's happening. I'm leaving Emma $50,000. She's giving a positive inflow into her bank account. She's going to take some of the money and do charity, but overall her positive U is, her delta U is going to be positive. So she's going to keep more money than she spends. So she can feel good about it, right? She's making the world a better place, but she's also going to like this because her bank account went up some. Okay? Call it a finder's fee. I'm okay with this. Okay? All right. So one thing left to do. And now we're going to take a line straight down. So if I take a line straight down, what's staying the same? This is the easiest one. This is why I saved this for last. What's staying the same? Volume. So if I have a horizontal line, what's my change in volume?
0.
0.
Defined.
No, it's not undefined. Okay, this isn't the slope.
Oh, okay. I'm in a different place.
Okay? So if I have a vertical line, what's my change in volume? 0. So delta V equals 0. How much work do you think is done here?
0.
No work at all. Why?
Because volume isn't changing.
Volume didn't change. Oh, so this is kind of like kids on a Saturday. Hey, there's no work. Okay?
I work every Saturday.
I'm kidding, James. Now, let's look at some numbers, shall we, kids?
Sure.
So we're going to kind of reconsolidate everything that we had. Okay, so we're going to take everything that we had, we're going to put it all into one kind of clean graph. So the first thing that we did is that we started here and we went like this, right? So this was 2440. That was a volume of 0.1. This was 0.5, right? Isothermal, isovolumetric, iso whatever. What's this line?
Isothermal.
Isothermal, right? So that means on this line, my change in temperature is going to equal what?
0.
Which means Q plus W has to add up to 0. Work is going to be positive or negative.
Negative.
So I've got a negative work, so that means that my Q has to be a,
Positive.
so that these two numbers add up to equal to 0. Energy flowing in, energy flowing out. Energy's flowing in. I'm giving him a money, but money.
Giving Emma that money.
I'm giving him that money, okay? So, Emma's got the money, but Sister Emma's going to do the work of the Lord. She's not going to keep any money, right? Okay? Praise the Lord. Hallelujah.
Amen.
I can't do that. I'll have the voice for it. Amen. All right. So, delta U is going to equal 0. Everybody's